Alright, you guys, today we're going to be talking about some definitions, and we're going to be going back to our Tools of Geometry dictionary again, but this time we're going to be talking about angles. So, our first definition is an angle. This is the intersection of two rays at an endpoint. Okay, so the intersection of two rays at an endpoint. And so my picture, if I draw my angle here, these are two rays that I just drew. They actually intersect at one point here. So if we have our intersection point right there, then this is how we actually identify this too. So that's our one endpoint. And then we would say that, let me do this a little bit thicker. So we would have A, this could be point B, and then we would have our other value of C here. And how we actually represent this, we have our symbol that's going to be read as angle A, B, C. And we always state the actual angle right here, this angle that we're talking about, that letter B, like right here for this instance, is always going to be labeled in the middle. Okay, then our next definition we have is our vertex. This is the common endpoint of an angle where the sides intersect. The common endpoint of an angle where the sides intersect. Okay. Intersect. Okay, so now to draw a picture for that, it's going to be this point right here in this picture, but let's just draw another one just so we can actually see it again. So we have our vertex is going to be this point right here. Okay, so and then I'm just going to write that the vertex is point B. And that's like right there if we were looking at this, all the little pointy areas. Okay, our next definition we have is a right angle. This should be review back from middle school, I believe, is when you guys started learning about that. So this is an angle most of you guys know with a degree of 90, a degree measure, sorry, of 90 degrees. Okay, so then for our picture here, what it looks like, it's that straight, it has to have the 90-degree angle. That little right, remember half square represents the actual 90 degrees. So this actually represents a 90-degree angle, that little symbol right there. Okay, so then we have our acute angles, and an acute angle is an angle with a degree measure that is less than 90 degrees. An angle measure, and again, that was less than, let me pause that. I forgot a couple words there. An angle with a degree measure less than, and that's the key point right there, less than 90 degrees. So for our picture, so we have to be smaller than this angle here. So for our picture, we draw an angle kind of like our up ones, our ones above that we've been writing. And this is, let's say that this is actually like 50 degrees. And there you go. So anything less than 90 degrees. Then we have our obtuse angle, and this is our angle with a measure, degree measure. Sorry, my handwriting is so messy. Measure, and this is going to be greater than 90. 90 degrees. Okay, so again, that's 90 degrees, if you can read that. So 90, and then these are the key words here, is that we want, like the acute is less than, and then this one is greater than. So for my picture, for my greater than, I have to be larger than that 90 degrees. So I'm going to draw an angle that opens up further than that. And we'll say that's about 120 degrees. Okay. Moving on to our next angle, we're going to be talking about congruent angles. And so these, you guys already know what the word congruent actually means. However, when we're talking about angles and congruent ones, these are angles that have to have the same measures, and they have to be this, they are congruent though. So angles that have the same measure are congruent. And remember that little symbol for congruent is the little squiggly line with an equal sign below it. So those are congruent angles. Let me draw a picture what that actually looks like. So we have our two angles here. Let's say these are about 40 degrees. And this one's going to be, this will be angle A. And we have the same one. This will be about 40 degrees, and this will be angle B. So they are actually congruent, and the way that we write this for our actual statement is that since so we have those 40 degrees there, so our measure of angle A would be equal to the measure of angle B, and since those are actually equal to, so they're both equal to 40 degrees, then our next little statement we would say is that angle A is congruent, a little squiggly, to angle B. So it's kind of our statement that we would say for congruent angles. Now we have adjacent angles, and our adjacent angles are two angles that share a common side and a vertex. And you guys, another word I just like saying basically is that they're next to each other. It's a lot easier to remember this. Next to each other. Okay, so let's draw a picture again so that you guys can see what I mean for this. So for our picture here, if we draw our angles, let's say we have, so we actually have an angle going between it, or a segment going between it. So this will be angle 1, angle 2. And what we say by that is that, so see how, if we actually look at the actual definition, two angles that share a common side, so this is that common side that they share, and its vertex. So these are the two main things that they're looking for to see if they share. Also, you can also see that 1 and 2 are right next to each other. So for our next one, we have vertical angles. These are two angles directly across from each other on intersecting lines. So again, two angles directly across from each other on intersecting lines. Most always you will see an X like this, and they're going to be directly across from 1 and 2, so that could be one of the options. And then 3 and 4 would also be vertical angles. So just to give you guys a heads up that these ones are always congruent. So you have the measure of angle 1 would be congruent to, or even equal to, the measure of angle 2. Okay, so always congruent. Let's make a little note. And we can use that little congruency symbol. Okay, now we have our complementary angles. These are two angles with measures that have a sum of 90 degrees. Okay, so again, the two angles with measures that have a sum of 90 degrees. So if we have our 90-degree thing here, we can have our little half triangle or half rectangle. This gets cut in half. So let's say that this is, or not in half, let's just say 65, and this one's 25 because this one looks a little bit smaller. So if I were to add 25 and 65, then that would get me to have 90. Our next one is supplementary. These are two angles with measures that have a sum of 180 degrees. You guys, just a quick little thing that a student once taught me. Just to remember complementary angles, that these add up to 90. So if you put a little slash to this first letter C, these two first letters represent the 90 degrees. You can see the 90 there. And then the supplementary, to make it 180, by just writing in the one before it and then connecting your S. And this is harder to draw on here. So your supplementary, what you would be doing is putting an 8 or 1, and then you have your S, but you would be connecting it so it looks like an 8, and then connecting your U so it looks like 180 for this section right here. Just little tricks to remember 90 and 180. So those are the little tricks that a student taught me, and it stuck with me, so I don't know if it would stick with you guys. So we have two angles with measures that have a sum of 180 degrees. Okay, so let's draw a picture of this, and I want to show you they actually don't have to be like adjacent. So this would be, let's say this is 120 degrees. And then if we had a smaller little like degree over here, or angle, sorry, of 60 degrees, then if we were to add those up, then they would be supplementary. 120 plus 60, then we'd have our degree equaling 180. Okay, our last four terms here. So we have a linear pair. These have to be adjacent. And when they are adjacent, it should be ADJACENT. Adjacent angles. Remember, those are the angles that are touching, they share a common vertex and a side. Adjacent angles that are supplementary. And when they are combined, they actually form a straight line. That's why they're called a linear pair. So what that would look like this time is that they actually are on the same line. So this would actually be our 120 degrees, and then this would be our 60. So this time, again, they are actually on form a linear pair, which is they form a line because they were adjacent angles. Then we have our perpendicular. These are two lines that intersect. Again, this should be a familiar word to you guys, but we're just reviewing it just because it's probably been a while. So two lines that intersect at a 90-degree angle. It has to be 90 degrees in order to be perpendicular. And then the symbol that we use actually looks like this. So that's how we know it's perpendicular. It actually makes two right angles, or two right, if you look right here, that's your two right angles, the little half squares. So just to draw a picture like that, let's do a different color. So there's our, it almost looks like a graph, but this time you have the right angle, and then you have, let's say that this is line L, this is line M, so you'd say L is perpendicular to M. So that's how the symbol is written. Then we have an angle bisector. This is a line or a ray that divides an angle into two equal parts. Okay, so again, a line or a ray that divides an angle into two equal parts. So if we have our angle, like with our two rays here, then the angle bisector actually goes directly through the middle of that, making this congruent. Let me draw a better little line right there. So again, it goes through here. I'm horrible at drawing these little crooked lines. Okay, so this is now congruent to this side, and these mean that they are both equal. Those little tick marks mean that they are congruent. The last thing that I wanted to, the last formula is our angle addition postulate, just like our segment addition postulate. This means that if we have the measure of angle ADB, let me actually draw a picture for this one first. So it's going to be very similar to our other picture that we just drew above there, because it's going to have the angle bisector. So we're going to label this one as point A, and we're going to label this one as, let's just do all these little points real fast, and then I can label all of them. So we have B, C, and then this will be D. Okay, so now I just did that angle bisector, which means that we have this side is congruent to this side. It might not always be congruent, so let's actually not do that. So this is just our measure of angle ADB. So What that angle is talking about, angle measure ADB. Remember I told you that the angle that we're talking about is in the middle? Well, there's technically two angles right here. So when it says ADB, you have to go to those points. It's only talking about that angle, the top angle right there. So we're trying to say that if we add that angle to the measure of angle BDC, and BDC, remember you follow it, BDC. Now we're talking about this lower angle. So the measure of angle BDC, this should all be equal to the measure of this entire large angle, the whole thing all together. So it should be ADC. And we will be messing a lot with this. So again, this top angle here plus this bottom angle should equal the whole thing. Okay, so that is the definitions for this next little chunk of our unit. I will see you guys in class, and we'll be reviewing these each separately and not all at once. All right, talk to you soon. Bye.